Alright, so today we're going to look at writing an equation of the parabola given the graph and directrix. So here we need to know that if the parabola is opening up or down, then it's going to follow this formula function y equals 1/4 p 1 over 4p x squared, and the focus is 0 comma p, where the p is on the y, remember, and the directrix is y equals negative p. So y. Okay, y. So what we want to do first is we want to find our p. So we know that the directrix is y equals negative p, so that means that the here, let's set those equal to each other. So negative p equals negative 7. You probably guessed it, p equals 7. Okay, that's not, you didn't need to show that work, but I just wanted to show where that's coming from. All right, now we know that p is 7, so we're just going to replace it with the p. Easy as that. Easy peasy. Hey, p. Okay, so 1 over 4 times 7 times x squared, and we want to leave the y and the x as a y and an x, okay? And we get y equals 1 over 28 x squared. Ta-da! That's it. Easy. And if the parabola opens to the left or to the right, then you want to follow the equation x equals 1 over 4 times p y squared. Focus is p comma 0. Directrix is x equals negative p. So x equals p's in the x equals negative p. So x. Okay. So keep that in mind. Let's find our p again. So negative p equals 3/2. All right. So again, p is just negative 3/2. All right. Again, you don't need to show that. So here, let's plug that into the equation. Oh no, it's a fraction. It's okay. Fraction starts with f, just like fun. So we have 1 over 4 times negative 3 over 2. And this one's going to be a little crowded. So we want to multiply. 2 goes into 4 twice, right? These cancel out. And we get 2 times negative 3 is negative 6 y squared. Ta-da! That's it. All right. Next one is where the vertex is not on the origin. So when the vertex is not on the origin, you want to follow this formula. And hey, does this look familiar? Yeah, it does. It looks like y equals a times y of x minus h squared plus k. Okay, so instead of a, we have 1 over 4p. Wait, is this focused? Good enough? Okay. So our h and the k, same thing as before. Okay, our vertex here is negative 2 comma 3. So negative 2 comma 3 looks good. And we just need to find, we have our h, we have our k. I'll label it. So our h is negative 2. That's our h right here. And our k is 3. Okay, labeling. And now we need to find the p. That's all. So how can we find the p? Oh, I forgot to label. This is focus. Okay, so this is the focus. And we have to label that point. That point is negative 2, comma, negative 1. All right, so notice that the x's are the same. Okay, when it opens up and down, remember, when it opens up and down, the x isn't changing. Remember that? The x isn't changing, it's the y. So here, our y is changing. So we need to find out how much it changed by. Okay, so we need to find the the p. So here, let's plug it in. We're going to set this. Okay, plus p equal to this one, -1. So -1. And we're setting it equal to the y of the focus, okay? Because that's where the k plus p is. So h, k plus p. So k plus p, we know our k is 3. Oh, it's right there. We know our k is 3, so 3 plus p equals -1. Subtract 3 from both sides, and we get p equals -4. Ta-da! So we know p equals -4, yay! Now what do we need to do? We need to just plug it in. Just plug those into the formula. So we got our p, we got our k, we got our h. We need to leave the y and the x as themselves, so y equals 1 over 4 times, our p is -4, times the quantity of x minus, and our h is -2. Okay, I'll make that positive. Squared plus our k is 3. And then simplify. 4 times -4 is -16 times the quantity of x plus 2 squared plus 3. Bada bing, bada boom. Finished. On to the next. Now, what if it's opening to the right or to the left? If it's opening to the right or to the left, you want to follow this formula. Okay, it's x equals 1 over 4p times the quantity of y minus k squared plus h. Wait a minute, that looks similar to this, except they switched the x and the y around, right? Switch the x and the y around, and they switched the h and the k around. Okay, so those are the only difference. Okay, but how do you find the h and the k? Same thing, vertex A. So our h here, oops, why did I put h and k? Our h is, so this point right here is 3, comma, -1. So our h is 3, our k is -1, and now we need to find our p, just like before. Okay, and since this is opening left and right, remember it's not the y that's changing, it's the k that's changing. Sorry, it's not the y that's changing, it's the x that's changing. Okay, so here instead of k plus p, like in the last problem, it's h plus p. So h plus p. X equals, so the x is changing. Okay, so this point right here is 4, comma, -1, right? So h plus p is 4, right there. You'll see that, 4. So h plus p. So h plus p equals 4, and our h, we know that is 3, plus p equals 4. Subtract 3 from both sides, we know that p equals 1. And that makes sense because it's only, the focus is only one space away from the vertex. Okay, just like over here, our p is -4. From the vertex it goes 1, 2, 3, 4 spaces. Okay, that's all it's telling us, how far away it is from the vertex. P, K, H, plug it in. So we have x equals 1 over 4 times, and I'm not in, there you go, 1 over 4 times p, our p is 1, times the quantity of y minus our k is -1, squared plus our h is 3. So x equals 1 over 4 times the quantity of y plus 1 squared plus 3. Ta-da! Finished.